Hello and welcome to Engineering Problem and Solution. So last time we completed this example question, which was the previous. If you watched the previous video, we have completed this example up to question number 5, and question number 6 is remaining. So today we're gonna finish that question number 6, and let's look at question number 6. So we need to find the torque applied to the drum. So for this we are gonna use the same thing which we have already calculated, and we're gonna stick with the same idea which we are going through from the last video. So on left hand side we're going to use formula, and right hand side we're going to use dimension lines to verify our answer. So for the torque, the formula we are going to use for the torque is I'm going to write TQ is for my torque. So my TQ equals to my inertia times acceleration, angular acceleration. And we know that our torque can be written as inertia. The formula for inertia is half times mass times your radius square of your drum, and times we already have calculated our angular acceleration from, if you go up from your number 4, which we have calculated angular acceleration of drum. So we have already got that value, which is 2.03. So we're going to use that value to find our torque. So let's substitute all the value which is known to us. So we have half times mass, for our case mass is 4 gram, and then radius we have diameter is 0.4, so radius is 0.2 square, and then times we have alpha is 2.03, and if we use this all and calculate in our calculator, we are gonna get 0.5 times 4 times 0.2 square times 2.03. We are gonna get 0.1624, and the unit of torque is Newton meter, and that's our answer here. Similarly, we are going to apply our dimension analysis. Now remember, when you apply dimension analysis, we have to convert every relationship into its fundamental dimension, which is length, time, mass. So we need to convert that. So we're going to use the same relationship of torque. So our torque is TQ equals to inertia times angular acceleration, and we know that torque is nothing but half mass times your radius square times your alpha. So what we're going to do is we're going to convert all of them into dimension, fundamental dimension. Mass is referred as capital M, radius is length, so it's going to refer as L. Your angular acceleration is referred as basically 2 divided by t. If you go back to question number 4, which you can see again, if you look the question number 4 here, this is our alpha, and we have 2 over t square. So I think, yeah, I need to put a square there. Right, so once we have those all, let's substitute that. So we're going to get TQ as half. We have mass. We have L square times we have 2 over T square. So this 2 and this 2 can cancel out each other, and we're going to get TQ equals to M L square and T minus 2, which is that t 1 over t squared can go up and become negative power. So once we have this, we can substitute the value, of all the value we have. So we're going to get TQ equals to mass is 4 gram, 4 kilogram. L is, this is referred as your radius, so we need to take the value of radius, not the distance cover or the cable of length. So we need to make sure that we are using a right value um, of length, which is 0.2 in our case here as our radius, times we have a time is, in this case we have 4, so our time is 4. So 4 minus 2. So if we use this and let's do in a calculator, we will get 4 times 0.2 square times 4 minus 2. So we are getting here value of 0.01, but this is not exact value of torque because we're still missing the angle. So what we have to do is we have to multiply the angle with the given value of our torque, and once we do that, we are going to get our exact value of torque. So going back to the previous example where we have calculated our angle, so you can see here we have already calculated the angle. So this is our angle, which is 16.25. We are going to use that angle in radian, so we're going to use this angle. So our angle is 16.25 radian. We're going to use that to find our torque. So we will get our torque, therefore our torque is going to be 0.01 times 16.25, and if we multiply that with 16.25, we are going to get 0.1625 Newton meter, and that's our torque. And you can see the results, and we can verify the results. Both have same answer, 0.1624 from the formula, and from the dimension analysis 0.1625, which is kind of, they are exactly same. Right, so now what we're gonna do is furthermore we have one interesting additional question here. It says use dimension analysis to develop equation for power using linear and angular velocity. Now when you look this first point, when you look this, it looks very complicated. It is really asking you to derive the power equation for the using the linear velocity and angular velocity, but it's not that difficult. It's very simple. So let's derive the expression. Typically, let's find the expression for the power for the linear velocity and the angular velocity. So let's do that for linear. So what I'm going to say here is linear power, and we need to make sure that we know the relationship for this derivation. So for linear power, our relationship is simply force times velocity. Basically, if we talk about linear power, that means it's linear velocity. So simply multiplying force with velocity, we can get our linear power. So let me write this as PL equals to F times V, right? And this is going to be, unit going to be Newton meter per second. Okay, and then PL, let's break down this furthermore. Force is nothing but force time mass times acceleration. So we're going to use that force is mass times acceleration times whatever velocity we have. Okay, so I'm going to write here as force is mass times acceleration. So what we're going to do now, we are going to represent our velocity and acceleration and mass, everything in our dimension. So our mass is referred as capital M. Now acceleration is basically is refer as in our example. So far we're looking at our example, is refer as your 2L divided by t square. And what about the velocity? Now similarly for the velocity, we have v is 2L, simply 2L divided by t. So if we substitute those value, and what we're going to get here, we are going to get PL equals to m times, let's use our acceleration, which is 2L divided by t square, times, okay, we have 2L divided by t. So let's simplify this furthermore. We are going to get PL. We have 2 and 2, we're going to multiply that and we're going to get 4. And then we have m, and then we have L and L, we're going to get L square. And then we have t over t squared times t, we're going to get t cube. And we can write this in a single line by making that positive power into negative power, it's going to go up. So finally we are getting PL equals to 4m L square t minus 3. And that is our formula for the linear power, from the dimension analysis. So that's what we are going to get, or if we use dimension analysis relationship to get that value. Now similarly, what we're going to do is we are going to go to the now angular power. Okay, so after this we are going to use angular power. Right, this, change that, angular power, and what I'm going to say this is as PA, okay, as indicate angular. And the relationship for the angular power is going to be torque multiplying with your velocity, which is, again, if you're talking about torque, then it should be angular velocity. It's not linear velocity, which is omega. So that's the relationship. So let's simplify this furthermore. Now what is torque? We know the relationship for torque is inertia times angular acceleration times omega, right? And we are going to use now again the relationship like we have used before, one by one. Now inertia has its own relationship, okay? So inertia has a relationship of half mass times r square. So I'm going to use that r as L square directly here. Similarly, alpha, if you remember the alpha, if you go back to top, you can see alpha is nothing but 2 divided by t square, and omega is nothing but basically 2 divided by t. So after getting all the information we needed in a fundamental dimension, let's use those information and get our PA as a value or as a formula. So we're going to get PA as half ml square, that is from inertia. Now for angular acceleration, we have 2 over t square times, now for angular velocity we have 2 over t. Okay, so once we have all of this, then we have PA equals to, let's add them together. We can have this and this cancel, so we left over is just 2, and then m is m, L there is just 2L, and then t you can see there divided by t is t cube, because they're t square multiplying with t, so we're gonna get t cube. Now we can write everything in the same line. That means we can send this to up, and that's going to be negative power. So we're going to get PA equals to 2 ml square t minus 3. And that is our expression for the angular power which we need to derive. And hence we have derived angular power dimension formula is 2ml square t minus 3. And similarly, we have derived for the linear power, which is 4m L square t minus 3.